Well, it's starting right now, so I would like to invite here to our virtual studio our first speaker, Alexander Savin, and the moderator of this talk, Tatiana. So please come to us and we will discuss the talk, which will start right now. Tanya, hi. Hi, Alex. How are you?
Yep, hello guys. Nice to be here. So, Alexander, the stage is yours. Yep.
So yeah, Alexander, may you share with us what would be your talk about? Maybe some general info?
I think on start of my presentation, I will share the information. So it's kind of spoiler, your question. So if you...
It's a spoiler.
Yeah, that's exactly what we wanted for.
So if we're ready, we can start.
Yep. Just a kind of question for from my side to our amazing hosts, guys. Have you had an experience writing some code in Scala? Because I did actually. So, what about you?
I do, and I don't really love Scala, so I don't think I'm the good person to ask this question to.
I'm just only talks from my side about Scala, and I'm not really think so far that I need to drill in Scala. But after Alexander's presentation, maybe I will change my mind. Let's see.
Okay,
But
so
watching us, please write your opinion about Scala. Do you like it or not? And what are you waiting from Scala? Please share your experience about this.
yeah, we are just about to start the talk. The very last thing I would like to say. So guys, we basically have 3 chats where you may send us questions. Yeah, we see your comments about microphones. We will try to adjust them during the talk. So 3 chats we have. First one and the main one is here on YouTube. So right here you may write us some comments, and if you write it on YouTube, we would be able to share these comments on the screen and everyone will see it. Second chat is in Discord. So in Discord you have a chat which names exactly like the talk you will listen right now. So why should you start learning Scala? You may write your questions there as well, and we will take these questions from there. Tanya, our moderator, will pick the questions from there for this talk. And also, we have a chat on Where community platform. So you may also write questions there. We will try our best to have a look on all 3 chats. I could not promise you that we will, but we will try our best to do this. Okay, I suppose that's it. Let's start the talk. Good luck, guys.
So let's start. Can you hear me? Tatiana, can you help me with the understanding what sound we have and we have vision of my presentation?
Yep, everything is cool. I see and hear us now in the stream. So, yep, let's move on.
Oh, cool. So let's start. And first of all, a couple of details about me. So my name is Alexander Savin, like Roma mentioned before. So I live software engineer at IPAN, Spain. So some highlights from my experience. I have 10 years of experience with JVM languages. My key competences in general is high-load architectures. So I like distributed systems like Hadoop, like Kafka or Spark. I like to work with the system that maintain the stream processing. And the core things from this talk, I Scala language enthusiast, so I like Scala. That's it from my side about me. And the short note before I start. So please feel free to disagree with the statement that I will make during my talk. So all of the decisions have trade-offs. So we can discuss it in the channel, in all the channels Roma shared before. So feel free to ask questions, highlight the disagreement with me, and that's it. And the next point in my list, so please don't make the assumptions or decision on the things that I will share with you during the talk, because it's not so productive ready things. So be minded and decide accordingly with your production system. So Let me describe a bit the format of my talk. So it's only 1 hour. I have the intro and 3 topics. And just to let you know that after each topics, I have the short gap. Then you can ask a question. Probably Tatiana will made it vocally, and I have a chance to answer. The significant point, I will share a lot of code in Scala. Like we discussed before, yeah, it's kind of new. I expect that it's a new thing for you, but feel free to skip the code, because the thing that I want to share is kind of idea about the things that we have in Scala, not exactly the examples of the code. My talk have name, why should you wake up tomorrow and start to learn Scala? Let me start with the similar things. I think all of you wake up tomorrow, definitely. And I think you wake up for learning because you're here on the Java On conference, so you're prepared for that. And the last part in my title is a Scala. I have a couple of images about what is exactly the Scala. It's a kind of model for auto or theater in Milan, but I don't think it's the topics that I want to discuss today. Actually, the things that I want to discuss is the Scala programming language. Some things that I want to highlight before I start about the language itself. So we have a short history summary. So in 2001, in Switzerland, Martin Odzierski started the language, and language have the second version in 2006. And right now we are in the process of the migration to the third version of the language. And that was initially started on 2020. Main point that you can run Scala on different platforms. But first of all, we are on Java On conference, so we mostly talk about JVM related topics. So most of the, almost all of the things that I will share with you related to running Scala on Java virtual machine. So Java can have the branches for execution with JS or Scala native, but it's out of scope for my talk. Let's start. So here on the slide, I have the ranging for the Scala languages for current year. And the Scala, you can see not on the top. So the question that we have, why we should learn Scala? Because it's so small and so kind of unpopular, I can say. And the answer looks like this. So it's the funny thing, but the answer is related to this meme. So let me, first of all, highlight the Scala properties that I think should be considered during the selection of the language. First of all, I think that Scala is not your first programming language. I think all of us on Java On conference have the background for the Java. So please start with Java as well. So it's not the thing that typically people start with Scala itself. I think the next point that Scala is kind of niche language. So we use it for the specific occasion. And that's why it's kind of small. The next 2 topics that I want to highlight that I kindly disagree, but it's still the factors for this kind of smallness. So first of all, I disagree with the thing that typically programmers say that Scala is for high society. In this specific case, I mean that to learn Scala and to understand the language, you have to know the category theory or upper side functional topics. But I don't think this is true right now. And the main point that typically related to Scala, that Scala is kind of better Java language. Let me start with such topic in detail and highlight that for a significant amount of the learners is a common way to Scala, so as a better Java. here on the screen, I have the two programs that I written in Scala and in Java. So, and this is the thing that we typically name better Scala. It's just a more compact way to express yourself. So here you can see that on the right side, we have Scala program that kind of significantly less verbose than Java one that we have on the left. As an outcome of that, so yeah, you can agree with me that it's a less count of lines of the code, but as this mem said, okay, Java have this issue for years. So what's else? And what else? I think that as a Scala language, Scala introduced a lot of things that typically right now in process of adopting to Java. So like you can see on my table, so time to time, Scala have out of the box all of these things like lambdas, type inference, sealed classes, and Java on the next version have probably most of all, but not yet. So, and I can say that Scala is a kind of source for features of features for Java. So right now, pretty impressive that Java on the way to pattern matching implementation, because I have it from out of the box from 5 years ago as minimum. So it is a kind of intro. So it's kind of general description about the Scala language. But my talk is what we have in addition to this term better Java. And my approach is to give you 3 types of things. First of all, to share with you how you can efficiency model the things with Scala, how we can use it with frameworks, and what kind of frameworks really based on the Scala. And the third one in my list is kind of special things that I think Scala is mostly valuable for. Let me start with the first one. So I think the idea of the programming is how to express or model the world efficiently. And I think the more easily we can do that, the more efficient is the language. I can give you two types of examples with the explanation how the Scala simplified such topics. So first of all is algebraic data types, and another one is blueprints with the help of framework of Zero. Let me start with the first one. What is the algebraic data types? It's kind of simple. It's kind of concept. So let me make a step back and explain the general approach for the programming languages. You have kind of model that you have to implement with your program. We have a lot of terminology in this area. So like model, special language, bounding context, but like the picture describe it. So we have a vision in our mind. So the basic points for our program, like in this case, I try to model the hotel booking system. For every hotel have their rooms, every room have the price, and we have a relationship between the price and room by booking. And of course, booking have the guest who make this thing. If we move forward with that, so we, like I said, we have a relationship between such topics. Let me ask yourself, let me try it in another way. So in a school, we made the same relationship between other things, like we have algebra during our education. Like we have national numbers, we have special operation like sum operation or multiplication. We know the laws between this operation, like associativity. And the question here, is it possible in general to make such approach with the algebra to the model that we have, for example, for our hotel and booking? And the answer, yes, we can do that. So we can do the relationship between the domain objects and maintain the laws. With the Scala language, so you can do it easily. So here I have the example of the implementation of the booking system with the Scala language. You can see here that we have rooms, we have several types of rooms. We have several types of guests, several types of prices, and the booking system. The main point here that we can maintain the laws between such entities. So typically we have two types of such things. So sum or. So it is implemented by Scala classes and Scala traits and case classes in the Scala case. So we have a pattern matching and all of the things from the language to express this. So like you can see on the screen, so the language itself help you to not skip gift type in the function. So the compiler will warn you about that. So the language itself help you to build more safety code. Another type of the relationship is a product. It's a simple one. So for example, booking have the components, so then they combine the room, the guest, and the price. So it's kind of product. With such approach then I showed you before, so we express the relationship with the Scala language. But the question here, is it algebraic data types can be implemented with other languages? Yes. And can it be implemented with Java? Yes, of course. So here I have the examples of the implementation with a different version of Java. And return back to the features that Scala have out of the box, I could say that Java is have the evolution, but still we have not all of the features. Even with the last Java, we still don't have patterns in switch statements. So I have to enable preview to implement that. But if I compare the last Java with the last Scala, as I have to do, so the last Scala 3 have even less implementation boilerplate. So we have just a couple of lines in addition. Let me make a conclusion. So I think that algebraic data types is a good representation for your model. It helps build a laws for this and try to maintain such laws in general is the main idea of the programming. And the Scala have the support for these things out of the box. So it's just ready, you can use it. The next point, what the other tooling that helps you to express the world or implement the things that you have outside of your computer. So is blueprints with Zio. So Zio is a special framework that based on Scala, and Zio generalized the conception of the calculations. So here we have three type of things. So we have environment type as an input, and as an output we have one or another, even error or failure type, even success type or kind of result that we expect. I think from this perspective, it's kind of more, it is as much as general representation for any calculation. Here I have the explanation what I mean about the blueprints. On the left, I have an example of the simple application that read your name from a console, waiting for 3 seconds for that, or fall back to default one name, and output the hello message on the screen. Actually, the representation of such program in WebZero framework, it's actual blueprint, so it's a plan for execution. So on the right side, I have the same representation as a graph, or maybe kind of representation of actual blueprint. But you can see that we have kind of plan for the execution, and only with such plan, we run it with a special method. I will return back to that a bit later with the additional features. Why? Because some of the audience could say it's a typical thing that have the functional programming languages as monadic computation. I don't want to dive deep to the question because my colleague, Karin Alexandra Manoid, have the brilliant talk tomorrow that I will appreciate you can attend. And I think Karin Alexandra shared a lot, much more information about functional programming and especially Scala or Java implementation for such things. Then I can, then I, with the limited amount of time for my talk. Let me make a summary. So I think the Scala is a language that perfect for modeling the world. We have two types of examples here. Algebraic data types, like I said before, is a good idea. And we can express the laws with the really compact syntax that Scala can give you. And another example that we can sketch the blueprints for our program logic, and as well with Scala and help with Zero framework, we can do that. So I finished my first topic. If you have questions, I'm really glad to answer.
Actually, I think that we have more like comments rather than questions. So I will sound some of them because we have a lot of stuff which has been said, and I think we will proceed with some more comments later on. But yep, some inspiring points like I love Scala, especially type inference is wonderful for my laziness. Yep, and there are some discussion points like Scala is good for using with Spark, which I think will be the next part of your speech. Spoilers, sorry guys. Yep, and the point that there is kind of a bit long comment about some concerns regarding Scala, so I think we will discuss it later on nearer to the end of the speech, because yep, it's rather interesting to hear your opinion on that. And yep, we have some comments in the community platform related to the fact that guys have started to learn Scala and it looks great so far, but need to see it in action rather than in toy examples, and I totally agree with that. Yep, so one more quite a long comment, but rather interesting. I think Scala is awesome. Just learning it will improve your coding skills, better object-oriented design, better use of type safety, functional programming, immutability by default. However, it's not an easy thing to learn for many people. It requires a sort of mindset change from imperative programming. Which many are reluctant to make. I believe that the reason why Scala is not so popular, and there are not too much good framework to use, like Spring and Micronaut don't support Scala officially. Using them with Scala feels forced. Scala framework like Legum are kind of intimidating. So, yep, I think this is the point which we also are going to discuss next. Am I correct?
Yeah, Definitely. So it's exactly what I want to highlight. So we have kind of answers in our next slides.
Let's move on.
So let's move to the next topic, and I have the interesting term on my screen, lingua franca, or common language. And this is the thing that I get from the Wikipedia. So definition for lingua franca is a bridge language or common language, a lot of things that with the language in the end. But the idea here that all of us, or most of us from different countries, and have the original language different. So we have to convince or agree on the common language that we can talk. For this specific case, I talk with English, not my native language, but I understand we can communicate with that. And the thing that I could say that lingua franca for Scala written frameworks is actually Scala. So that's why the Scala is the core point here. Let me start with explanation of some of the frameworks that we have based on the Scala. First of all, and first in my list, I think all the Spark, Apache Spark is the first in the list for Scala language for every discussion. I think it's really widely used engine for scalable computing. So the Spark can be executed on different platforms. You can set up the standalone Spark cluster. You can leverage the Yarn resource manager or just run it on a Kubernetes. Spark provides you the ability to batch or streaming processing. Couple of topics here that Spark has special language as Spark SQL and special abstraction on top of the distributed data set as data frames. So, of course, Spark is widely known as a framework for machine learning because most of the operation will be applied on the memory and is a significant game changer in comparison to, for example, Hadoop. The point that I want to highlight here, Apache Spark has Scala as a source code language. So, and I have kind of joke here that in the quick start tutorial, they have only 2 options for you. Of course, they have a lot more options in the other pages, but I really surprised that on the quick start, you have only 2 options recommended by Spark documentation. You have to use Scala or Python. Of course, the thing that I want to highlight, so if we have framework written on Scala, so here the Scala is a kind of lingua franca language. I don't want to dive deep to the Apache Spark more than the couple of minutes. That's why, because we have tomorrow the brilliant talk, especially for that. So Oleg Klimenko will share with you the information how to run Spark. So the interesting topics that will be covered with the, and I think it's core point of the talk with the live coding session. Let us switch to another, not only Spark based on the Scala. Apache Kafka is a well-known distributed log framework as well have their core on the Scala language. Kafka is a conception of distributed log, like I said. So we have actually queue. So the queue is distributed over the topics. Every topic can serve the producer, and consumer will read on one topic on several topics. The system and framework well known as highly available and the key point of exactly one processing. So the Kafka is scalable event streaming platform written on Scala. Of course, here we have a lot of things in Java. But as I mentioned before, the Scala is the core language or such framework. I think that is kind of things that you have to do. So if it's written on Scala, the easy way to interact with the framework is the Scala itself. Let me switch to the next framework that I have in my list. It is my favorite one, actually. So it's the Akka framework. If you don't know about actor model, I will encourage you to understand the concept of that. Akka is the implementation of this actor model on the JVM. Actors is actually actors, so they act with some. So they receive. Actor is an entity. In the entity receive the messages. Every message can change the internal state, and this kind of the things, this simple concept, give us the 4 points of reactive architecture. So we could build a responsive system, resilient, be elastic, and like I mentioned before, actors itself message driven. So if you don't know what is reactive manifesto or reactive system, please follow the link that I shared here. I like the Akka a lot because of that. So with the help of such framework, you can build reactive system easily. And the things here that Akka as well based on Scala. Here I have the simple example. I understand that on the left side, the Scala is much more smaller than the same implementation for the actor behavior on the left side with the Java. The Java itself is pretty obsolete, so I understand that with the final Java, the code will be much, much smaller, but the fact that the documentation for current moment looks like this, so the maintainers of the Akka, of course, enforce you to use Scala as a main language because it's too much easily in comparison to Java. I have to highlight some of the other frameworks that I summarized here with less attention to that. So we have Flink based on Scala. It's a special framework that gives you the ability to maintain the stateless computation on the streams. We have Finagle as extensible RPC system. So here we have the answer to the question in the chat about the framework. So Finagle from Twitter, they built on the Scala the kind of framework that then you can build a network stack for distributed system. So I think that it's kind of recommendation from my side about such environment to build such things. And from the other area of the spectrum, for the load testing, we have a Gatling. Gatling is a framework to build load test of the code. So if you want to test your application in a performance characteristics, like, of course, it's usually the kind of HTTP service or something like that. So the Gatling is the thing that you help to express your patterns and reach your goals easily. And as well, Gatling based on Scala. So I think they just encourage you to write the patterns in the Scala language, and that's it. Let me make a conclusion. So I think this terminology about lingua franca express my point very well. Scala is a lingua franca for Spark, Kafka, Akka, and our frameworks. They have the source code in Scala, and the compact system on the Scala encourage you to use the language because it's too simple to communicate the Scala written frameworks entities, and that's it. So we have next area for the questions.
Yep, and there was a question which basically related to the previous section, but I unfortunately didn't have enough time to sound it yet. So the question about the algebraic data types, which type of natural numbers does Scala use? So is it starts from 0 or from 1? So kind of classical programming feature, like to start calculation from 0 or from 1. How does Scala work with that?
I think the algebraic data types is a concept. So I don't think it's related to this specific topic. The representation for the numbers on the Scala is the integers or longs. So I think it's slightly unrelated to algebraic data types. But from the idea of algebra data types, you can implement the logic by yourself. So and we have a lot of such implementation in the functional programming frameworks that I don't have time to express here. So for example, you can define something like non-negative number, and this have to be a non-negative number in any case. So if you have the boundaries, that's it.
Okay, got it. And yep, two more questions which are mainly related to this section in particular. So first one, what would you say about the performance of Scala compared to PySpark? Back in time, I used Python for our Spark-based project. Would be interesting to know what could be improved there and whether it's worth rewriting it in Scala.
I don't can't recap it completely, but well-known book from the area is High Performance Spark. And High Performance Spark, as I remember, said that if you have a choice between the Scala-based computation or Python-based, of course you should use Scala because it's kind of native language. The Python itself translates your computation to the bytecode by Scala framework. So I think it's more natural way to use Scala as an origin language than the Python here.
Okay. Sorry for being possibly a bit loud. Yep. Actually, the next question is about the frameworks as well. Have you had an experience to use Akka as a production project? An in production project? Yeah.
Of course, yeah, several times. I think so. I think it's a tricky question. So in the past, yes, I have a lot of examples of the production working application. The trickiest of the question that right now the Akka in kind of gray area with the change of license. So for the future projects, I think it's a kind of the questions. Should we use the Akka itself or fork of the Akka that I think we'll have in a couple of months. So I think guys from Zero try to fork the concepts of the actors as well.
Okay, thank you very much. And yep, I think that there are a lot of questions in both of the chats, so I will leave it nearer to the end because they are not directly about this particular section. So let's just move on to the third part.
Perfect. Let's just move on. Let me make a recap. The third part is description for the special cases that I think the best match for the Scala. I have two examples to share with you. First of the example is domain-specific languages with Scala. Let me express the topic. Domain-specific languages is a kind of things that we have domain terms. I think a good example, just to simplify things, is plain SQL. SQL it's not a programming language. So it's kind of specific language in specific areas. And the things that I have on the left is applicable for SQL as well. So it's easier than arbitrary programming language to read or write. It have limits. So, for example, it can't, or I don't know how to write the special SQL query that express, for example, arbitrary computation or arbitrary program. I don't think it's possible. So we have limits. But on the other side, every domain-specific languages have the requirements. So they have to be interpreted in some way. So we need an interpretation phase. So we have to transform with domain-specific languages to our form to execute. And as an outcome for the previous point, we need supported tooling, because if SQL fail in some point, in some cases perform worse, you have to have the special tools to understand what's going on here, how to get the point of the bottleneck. I think SQL here is a good example. So you have to do it for if your SQL query doesn't perform well. So we have special tools like explain or other things. Depends on the relational database you use. The point here related to Scala that for some specific cases, we can combine both of the things. You can use the Scala language itself without additional interpretation as domain-specific language. And it will be validated in compile time. Let me provide you an example. You can see on the right side on my screen the example program. Then I try to write the currency converter. So we have euros, we have bitcoins, and we try to convert one each to the other in some form. With Scala, it is possible out of the box. So let me provide you just two of the several things that we can leverage to express such good language. So first, it will be the methods with operator names and expression methods. Here I have to highlight it again. So I understand that the Scala programs itself is not the things that you can understand out of just from scratch. You can see that maybe it's kind of cat that walked on the keyboard and that's it. But I have to recap. The idea here is to express the ideas. So just follow the ideas that I will share with you. Doesn't matter that you don't understand the program itself. So first of all, Scala have the point of operators. Well, it is impossible with Java. So in Scala language, you can define the methods with arbitrary names. Like for this case, I defined the method with the plus name, and I can just express the amount in euros and amount in the bitcoins and sum them with the just plus method. So it's just a regular method. You don't have to use dots in the Scala world, and you just can type it on a line, and it will be the valid code in Scala. The next point that I want to highlight is that we have extension methods. For the same class amount, you can define the special methods that can express and apply some function on it. For this specific case, we can define expression methods with the names euros or bitcoins and the value of such things like kilo bitcoins or kilo euros or mega for the euros, and it will be the actually valid code. So you can just define 21 kilo heroes or 5 Bitcoins, and that's it with the Bitcoin well-known icon. So I don't think it's possible in Java. If you know the way in the compile time, feel free to say me how to do that. So let me express the idea again. Scala at some point can be just the DSL itself. So it's just a plain Scala. So as a final of my previous implementation, I defined a simple language. When I defined euros or Bitcoins with a plain language and just make a sum of them with the result. So you can see that I just want to highlight it's plain Scala language. So it's not kind of interpretation of the something that we have to transform to JVM to the bytecode. It's just a plain Scala language. So here's the idea. So we can use the Scala language as a DSL itself. It is a kind of highlight conclusion that I already made. So in addition, I want to say that it's not only two things. In addition to that, you can leverage other things like smart constructions, implicits, and all of our syntax sugar that Scala provides you to simplify the definition of your DSL. Sorry, but I don't have enough time to express it in a full way. The next point that I want to touch a bit is a program as values. It's another area that I want kind of the areas then Scala give you the more power than other languages. Here we return back to the example that I have on start with Zio framework and blueprints, like I mentioned initially. So the same program. Just to recap, so we have a hello message. It asks for the name for the user, wait for 3 seconds for the input, and fall back to unknown name, and greet the user with the name. And here, I want to return back to the conception of blueprints. In addition to just concept of blueprints, we can think about it like from the execution perspective, what we can do with blueprints. And like blueprint for the building or some machine, the things can be executed, of course, like a program, but we have another properties, like one blueprint can be composed with other one. So we can combine them together and run together. So it's the good property that we can leverage. In addition, of course, our blueprint can be introspective. It's like a blueprint for building. It can be reviewed by qualified engineer and can be improved. So the good point here that our blueprint can be optimized, and the result will be much more optimal than initial one. And all of these things can be done in our interpretational phase. Of course, if we have a blueprint, the next point that we actually can serialize or deserialize the blueprint is the good property, especially for distributed execution. And here we return back to the power of Spark or Akka framework, when you can do distributed computational on a lot of nodes. And the things that then you have the plan or blueprint of your computation, and it can be serialized and spread across the network. Of course, it's a critical value to have the easy distributed computing. Another point that I just want to highlight here about the program as a values. So as a blueprint is a kind of value you can share, you can serialize or combine. The interesting thing that with example of zero framework, we can not only combine things, but because it's our rules or our laws that we maintain, we can ruin them. For example, our program just wait 3 seconds and after that fall back to unknown. Typical approach here, or common approach in the unit testing, is just to wait more than 3 seconds a bit and test that we have something in the output. With the zero framework, when we have the blueprint, we can break the laws and just to adjust the time. It's just the adjustment of the time in the context of our execution. It's not the real time. So you can see here that we don't have to wait 3 seconds or more. It's executed in the milliseconds. So it's another point that program as a values give you as an idea. So you can, the value itself can be interpreted a bit differently. So you can break the rules and, for example, adjust time and just maintain them. So of course you can imagine that you can run a lot of tests in the same 3 seconds in comparison to just common approach. Here, all of the things that I want to share as program as a values. I don't think it's kind of full explanation of the idea, but just my approach is to give you kind of things to think about and to return back later with the kind of ideas. Let me just make a general recap. So why to learn Scala, actually? First of all, I think all of you, if you start with Scala as a better job. But in addition to that, you can leverage some of the properties. Like you can model the world efficiency with the blueprints or algebraic data types. Of course, interaction with the frameworks that have the lingua franca as a Scala, like Spark, Kafka, Akka, the interaction with them can be much more easily because with the Scala itself. And for the special occasions, like construction of complex DSLs, or especially DSLs when you can use, if you want to use the compilable Java Scala code. And blueprints that I mentioned before. So then you want to use the program as a values when you have a plan to execute, and after that you want to combine some things or distribute the computation of the frameworks. So the Scala have a lot of features and benefits on such areas. And I consider you have to use the language for that for sure. And of course, it's not the full list of the properties here. So let's just have fun and learn Scala for fun, for sure. It's a valid point. And that's it. So thank you for the attention. It was the last topic in my list. Tatiana, I think if we have questions, I can answer. But before you highlight some of them, in addition, I want to share with you some of the materials that can help you on the path to Scala. So feel free to see it on the screen.
Yep, and I think we definitely will attach all links below our event in the community platform. So please feel free to return back to the page later, and we place the links to the comments So basically, you've already replied to one of the questions, which sounded like which books you would suggest for learning Scala. So yep, it's amazing. Actually, we can see all of them on the screen. Yep, and returning back to the questions from the very beginning of our sessions. So there's a point like I worked with Scala for 2 years and have several concerns. So first one is slow compilations. The next one is binary incompatibility, which makes Scala upgrade especially difficult. Binary incompatibility means if you use any libraries written in Scala, they are not compatible. I mean, you want to use a new Scala version, your code won't work with the old libraries. So what do you think about that?
Let me answer by points. What I remember the last question about incompatibility for Scala version, but what is the first one?
The first one was about slow compilation time.
Okay. It is true about the slow compilation. So then I switched to Scala. So right now it's kind of magic for me. Then I return back to the Java world and just compile the Java programs, and it was really fast. I think the answer to this question is is it exactly the program? So if you think about the experiments on your idea, the Scala have a lot of tooling around with the caching and how to help you to compile really incrementally. So from the developer perspective, I think it's pretty solved. From the maintainability perspective, so if you compile your Scala code to the bytecode and just execute it, you have to do it only once. So I don't think it's a problem when your CI/CD system compiles. So the difference here is I don't think it's kind of critical one. So the second question is about the incompatibility, binary incompatibility.
Yeah.
The Scala community make a lot of improvements in such area. So your experience with the Scala, the compatibility, not of the Scala 3 with the Scala 2. Especially Scala 2.14 version. So the language and compatibility much more smooth than, for example, Python 2 and Python 3, despite the version match here. So my answer here, Scala community improves such things a lot. So I want to encourage you to recap and try it again, so just to get the real experience.
Okay, got it. Thank you. I think we have time for something like 1 or 2 questions more. So I will also return a bit back to the questions from the platform. And guys, I would like to point out that in case if your question is not answered during our session, do not be afraid. We will continue our session in Discord. We might sound some questions there. And if you're not going to participate in this discussion, then also do not be afraid that your question won't be answered. We will try to post as much questions as we can below our talk on the community platform with replies from our speaker. Yep, the last, I think, question which we still can sound during the stream. So let me choose something interesting. Yep, I think that okay, so this was something which we've already heard. Yeah, with operator overloading, is the precedence of all user-defined operators equal? For example, is 1 plus 2 multiply 3 equal to 7 or to 9? So with precedence or without it?
Good question. Partially, yes. So I can't provide you exactly the mechanism itself, but with the naming and so, for example, this kind of definition, when we know that multiplication is a kind of star in the Java language, and in plus in the is a summary. Scala have order of such method names, and I think for the simple cases it will just work, but you have to check. So partially yes.
Okay, got it. Roman, do we have time for one more question?
I think no, we have time pretty off. Sorry for that. So first of all, thank you very much for great talk. Thank you very much, Sasha, for opening our conference, and thank you, Tanya, very much for moderating this and bringing questions here.